Hello students, welcome to Anne's classes. Let's do Playing with Numbers, Chapter 5, Exercise 5a. We are doing question 5. If the sum of the number 842 and two other numbers obtained by arranging the digits in cyclic order, if it is divided by 111, 14 and 37, what is the quotient? That is what we are asked to find out. So this is a number and two other numbers obtained by arranging this in cyclic order. So according to property 3, okay, so we have learned some properties. According to property 3, when ABC plus BCA plus CAB is divided by 111, the quotient will be A plus B plus C. So here, the cyclic order of 842. Cyclic order means we rearrange these numbers. So cyclic order, now you can put 4 in the ones place, 4, 2 and 8. And then we can put, now this time in the ones place, we can put 2, 8 and 4. So here we've got 3 numbers now. So here it says when ABC plus BCA plus CAB is divided by 111. That is, this is ABC. We've put it in cyclic order. We've got BCA and we've got CAB. Now, if we divide these numbers by 111, our quotient is simply A plus B plus C. So, if I take 842 plus 428 plus 284, then the quotient that I get when I divide this by 111. If I divide this by 111, my quotient will be A plus B plus C. So I don't even have to actually add up everything. All I have to do is A plus B plus C. So how much is A? A is 8, B is 4 and C is 2. Now 8 plus 4 is 12. 12 plus 2 is 14. So my quotient is 14. So straight away we can say the quotient is 14. You can also check and see. You can add it all up, divide by 111. Your quotient will be 14. So according to property 3, we can do it this way without doing the actual addition and actual division. So according to property 3, this is one part of it. Now we have found the answer to this. So when we divide it by 111, our answer is 14. Now according to property 3, again, when ABC plus BCA plus CAB is divided this time by A plus B plus C. Now A plus B plus C is 14. When it is divided by that, then the quotient is always 111. So again, let's take this. So A plus B plus ABC means 842. BCA is 428. CAB is 284. When this is divided by, and here it says A plus B plus C. And we just found out A plus B plus C is 14. So when this is divided by 14, the quotient is 111. So 111, this is our answer. So here also, in this case also, we don't have to actually do the addition and the division. We just have to follow this property. So our answer here is the quotient is 111. So here it says if the sum of this number and two other numbers obtained by arranging the digits in cyclic order, when it is divided by 111, we found the quotient is 14. When it is divided by 14, we found out that the quotient is 111. Now we have to see what happens when we divide it by 37. So let's do that. So first, the cyclic order of 842. So we said the cyclic order is 428 and 284. Now here what does it say? When we divide this by 37, the number is 37. So we have to, here 842 plus 428 plus 284. So in this case, we have to do the actual division, the addition and the actual division. So add up these three numbers. When you add up these three numbers, you get 1554 and divide this by 37. When you divide this by 37, your quotient is 42. So we've got all three answers. So this is the third answer. So when we divide the sum of 842 and two other numbers arranged in cyclic order by 37, our quotient is 42. Question 7. If A star B is equal to 2A minus B minus 2, now this we know. A star B, the operation can be anything there. If that is equal to 2A minus B minus 2, now we are asked to find the value of 8 star 7. So in this case, what we do is take this and this. So here you can see in the place of A, we can write 8 and in the place of B, we can write 7. Now let's work out this. So what is that? That is 2A minus B minus 2. So we're going to substitute for A is 8 and B is 7. So let's do that. So 2A means 2 into A. 2 into A is 2 into 8 minus B, which is 7 minus 2. So 2 8s are 16 minus 7 minus 2. So this will be 16 minus, now you can do it straight away. 16 minus 7 is 9. 9 minus 2 is 7. So here the answer is 7. Question 8. In each of the following cases, find the least value or values of the letters used in place of digits. So here we can see A and B, isn't it? So these are letters used in place of digits. Now we have to find the value of A and B now. So let's look at the first one. Now A plus 5, here it says 2. That means clearly when you add up A and 5, you get a number whose ones digit is 2. So suppose I say A plus 5 is 2. I can also say A plus 5 is 12 because the ones digit is 2, or A plus 5 is 22. It can be any number as long as the ones digit is 2. Now here we are asked to find the least value. Okay, so let's take this. A plus 5 is 2. Now let's find the value of A. If A plus 5 is 2, then A is equal to 2. And we move this plus 5 to the other side, it becomes minus 5. So 2 minus 5, so this is minus 3. So A is minus 3, which we can't put here. We can't put minus 3, the negative 3 there, isn't it? Let's go to the next one. A plus 5 is 12. So in that case, A is equal to 12 minus 5. 12 minus 5 is 7. So we can put 7 there. Now let's continue here. A plus 5 is 22. It can be 22, it can be 32, it can be 42, it can be any number. I've just taken this. So A plus 5 is 22. So A will be equal to 22 minus 5, which is 17. Now if you go on, you will get many more values for A. Now here we are asked to find the least value. That means the smallest. Now here minus 3 cannot be put there because it's negative. Now the next smallest number between 7 and 17 is 7. So in the place of A, we can put 7. So A, we have found the value of A. A is 7. Now we need to find the value of B also. So now let's put it there. Now in the place of A, we're going to put 7. And then we have 2 and 5. And on adding this, what do we get? We get B and 2. So to find the value of B here, all we have to do is add up all these. So 7 plus 5 is 12, so we carry 1. When we carry 1, here it is. 3 plus 1 is 2, 2 plus 2. 3 plus 1 is 4, 4 plus 2 is 6. So it is 662. That means we have found the value of B also, and B is 6. So the value of A is 7 and the value of B is 6. Question 8, here we have A, B and C here. Now we need to find the value of A. Now 8 plus A will give you a number that's ending in 3. So let's see that. So now if I write 8 plus A, 8 plus A will give me a number that's ending in 3. Then A is equal to 3 minus 8, which is minus 5. So negative 5 we cannot take. Now 8 plus A can give me 13 because the ones digit is still 3. It can be 13, it can be 23, it can be 33. Remember, we are looking for the least number. So we have taken 13. So now in this case, A is equal to 13 minus 8, and that is 5. So 5 we can write. So because it's a positive number and it's the smallest number. So we have found the value of A. is equal to 5. So let's write that A is equal to 5. So now we're going to substitute in the place of A, we're going to write 5 and see what we get. So here, let's write this 98 plus 4, and in the place of A, we just found out what A is, that's 5. Let's add it up. So 8 plus 5 is 13. We carry 1. 9 plus 1 is 10. 10 plus 4 is 14. Now we have found the value of B and C also. So B is 4 and C is 1. So we have found the value of A, B and C. So question C, here we have A and here we have B. Now let's work on the ones column first. So 1 plus B is going to give us a number that's ending in 0. That is, the ones place is going to be 0. So 1 plus B is going to be 0. So in this case, B is equal to 0 minus 1, which is minus 1. So negative 1 we cannot use. So let's go on to 1 plus B is equal to 10. So it can be 10 because 0 is still in the ones place. So 1 plus B is equal to 10. So now we can find the value of B. B is equal to 10 minus 1, which is 9. And 9 is our answer because we are asked to find the least number. Remember, in the place of 10, you can put 20 or 30 or 40, but you will keep getting bigger numbers. But here in this case, we are asked to find the least number. So here B is equal to 9. So we can write that. So we have found the value of B. B is equal to 9. Now we can find the value of A by substituting. So let's write that A, and then we have 1 plus 1B. Now in the place of B, let's write the value of B, which is 9. So now let's add it up. 1 plus 9 is 10. So we carry 1 here. Now here 1 plus A plus 1 should give us B. And how much is B? B is 9. So let's write 9 here. So now altogether this should give us 9. So 1 plus 1, we already have 2. 2 plus what will give us 9? So A is 7. How did A become 7? So let's say write it like this. 2. We added up. 1 plus 1 is 2. 2 plus A is equal to 9. So now we can find the value of A. We can say A is equal to 9 minus 2. So A is equal to 7. So we have found the value of A also. A is equal to 7 and B is equal to 9. So these are our answers. Question D, here we have A and B in different places here. It's a 3-digit number. All three are 3 digits. So let's go carefully. Now B plus 1 is equal to 8. So let's write that. So B plus 1 is equal to 8. So that means B is equal to 8 minus 1, which is 7. So B is equal to 7. So now wherever we have B, we can put 7. So here we have a B, here we have, and here also we have. So let's write down this question here now. So 2, A we don't know, we're going to find out. A, in the place of B, we're going to write 7. Again, we don't know A. B is 7, 1. Now when we add this up, we should get, now B is 7, 1 and 8. So 718 we should get. So now let's find the value of A. Let's see, 7 plus 1 is 8. Now A plus 7 is equal to 1. So let's write that. So A plus 7 is equal to 1. So now we have to find the value of A just like we did in the previous questions. So A will be 1 minus 7, which is minus 6, negative 6. So A cannot be negative 6. So let's go to the next one. So A plus 7 is equal to 11. Remember, the ones place should always be 1 here. So A plus 7 is equal to 11. Now let's find the value of A. So A is equal to 11 minus 7. 11 minus 7 is 4. So now our value for A is 4. And we can check that by substituting A with 4. So let's do that also and see. So we have 2. So in the place of A, we're going to write 4 and then 7 plus, again in the place of A, we're going to write 4, 7 and 1. Now add it up to see whether you're getting 718. If you get 718, then A is 4 and B is 7. What we found out is correct. So let's add it up. So here we have 7 plus 1. 7 plus 1 is 8. Then here we have 4 plus 7, which is 11. Carry 1. Then here 1 plus 2 is 3. 3 plus 4 is 7. 718. So we got the same thing when we substituted for A and B. So now we know the value of A. A we found out to be 4 and the value of B we found out to be 7 as we found out here. Here we found A and here we found B. So we've got our values 4 and 7. Question E. Here we have A, B and A. Now look at this. A, B, both are unknowns. Now it's going to be difficult when both are unknowns, isn't it, to give you this sum. So either one of these you should know. So what we're going to do is we're going to take the second column. 2 plus A will give us a number ending in 0. So we're going to take this middle column and try and find the value of A. So once we get the value of A, we can put it here and then find the value of B. So let's try that. Now 2 plus A should give us a number ending in 0. Therefore, A will be 0 minus 2, which is minus 2. So that means A is negative 2 and that cannot be the answer. We cannot have a negative 2 here, isn't it? So let's try another number. So 2 plus A will give us, what is the next number? 10. Okay, because it should end in 0, I've taken 10. You can take 20, you can take 30, but we are looking for the least number. So 2 plus A is 10. Now let's find the value of A. A is equal to 10 minus 2. So 10 minus 2 is 8. That means the value of A is 8. Now we can find the value of B. So we have found the value of A. Keep that in mind and substitute. Wherever we have A, let's put 8 and then find the value of B. So let's take down the question. So that is 1, 2. In the place of A, we're going to write 8 plus 6. Again, in the place of A, we're going to write 8. Now B we don't know, so we're going to leave it as it is. Then here in the answer also, in the place of A, we're going to write 8, 0, 9. Now we're going to find the value of B. So 8 plus B is equal to 9. So let's write that 8 plus B is equal to 9. That means B is equal to 9 minus 8. That means B is equal to 1. So we have found the value of B also and B is equal to 1. So that's our answer. A is equal to 8 and B is equal to 1. We've got both the answers. Now, if you want, you can even substitute for A and B in the main question and see whether you get your answer right. Question F, 1A into A is equal to 9A. So this is a multiplication sum. We need to find the value of A. Now, since A is in the ones place, it has to be a single digit number. It can be any digit from 0 to 9. So we are going to substitute A with all these numbers and get our answer. So if A is equal to 0, so here we have 1A into A should give us 9A. So let's put 0 in the place of A and C. So 1A means 1, 0, into A is 0, 9A, 9 and 0. Now this is 10. 10 into 0 will give us 90. It will not give us 90. That means A cannot be 0. So take off A to be 0. Now we're going to try with A is equal to 1. Let's substitute A with 1 in this question. So 1A into A should give us 9A. So let's try that. 1, A is 1. Into A, again A is 1, should give us 9A, 9 and A is 1, should give us 91. Now here we have 11. 11 ones are 11 and not 91. So A cannot be 1 also. So cross it out, A is not 1. Now let's substitute A with the next digit. That is, here we took A is equal to 0. It's not fitting. A is equal to 1 is not fitting. Now let's take A is equal to 2 and C. So in the place of A, we're going to put 2. So 1A into A should give us 9A. So 1A means 1 and A is 2. Into A is 2. 9A is 2. Are we getting this? Let's multiply and see. 2 2s are 4. It should give us 4, but here we have 2. That means this also is not fitting. So A cannot be 2 also. So now we're going to go to the next digit, that is 3. Let's try A is equal to 3. We're going to substitute A with 3. So again we have 1A into A should give us 9A. So 1A is 3 into A, again 3, 9A, 9A is 3. Now let's multiply and see. 3 3s are 9, not 3. That means this also is not working out. So A cannot be 3. Now we are going to go on to the next number. We tried with 0, 1, 2, 3. Now let's try A equals 4. So in the place of A, we're going to put 4. So 1A into A is 9A. So 1A means 1, 4 into A is 4. Should give us 9A, 9, 4. Now let's multiply and see. 4 4s are 16 and not 4 here. So here itself you can make out it's not working out. That means A cannot be 4. Now we're going to try with A equals 5. So A is equal to 5. So 1A into A, 1, 5 into A, 5 should give us 9A, 9 and 5. Now let's try this. 5 5s are 25. 5 is correct. We carry 2. Then we have 5 1s are 5, 6, 7. This should be 7 and not 9. That means A cannot be 5 also. Now let's go to the next one. Let's make A equal to 6. So A is equal to 6. So 1A into A. 1A is 6 into A is 6. Should give us 9A, 9, 6. Now let's multiply and see. 6 6 are 36. So this part is correct. We carry 3. Then we do 6. 1s are 6, 7, 8, 9, 96. That means 16 into 6, 96 is correct. So we can substitute A with 6. So the value of A in this question is 6. So let's write our answer. A is equal to 6. So this is our answer. Question G, A, B into 6 and the product is B, B, B. That means whatever the value of this B is, all three B's will have the same value including this B. Now this is multiplication, so B here will be a one-digit number. So let's try and find the value of B. So one-digit number means starting from 0 to 9. So if we say B is equal to 0, then here A, B will be A into A0 into 6. And since there are 3 B's, the answer is going to be all 0. Okay, now, and this is not possible. So B cannot be 0. So now we'll go on to the next digit. Can B be equal to 1? So if B is equal to 1, then here the question is A, B. So here we'll have 1 and here we'll have 1, 1 and 1. Let's see if that is possible. So A, B is 1 into 6 will give us 111. Is this possible? Let's see. Let's multiply and see. 1 into 6 is 6, isn't it? Not 1. So this also is not possible. That means B cannot be 1 also. Now let's take B to be equal to 2. So in the place of B, we're going to write 2. So A, B is 2 into 6 and the answer is 3 2. So 2, 2, 2. Now let's multiply and see. 2 6 are 12, carry 1. Okay, so we have here. So now we can find the value of A and see whether it's possible. Now 6 into A plus 1 should give us 22. We already got 2. 6 into A plus 1 should give us 22. 6 into what will give us a number close to 22. 6 3s are 18. 18 plus 1 is 19, but we need to get 22. That means it's not possible for B to be 2. So this also is not fitting. So we have to go on to the next one. This time let B be equal to 3. So in the place of B, we're going to write 3. So A, 3 into 6 and the product is 3, 3, 3. Multiply and see if this is possible. 3 into 6, 3 6 are 18, but here it says 3. That means this also is not possible. That means We cannot have b to be equal to 3. So now we go on to the next one. Let's try and make b 4. b is equal to 4. So in the place of b, we're going to write 4. So a 4 into 6, and here we have 4, 4, 4. Let's see if this is possible. Let's multiply. 4 6 are 24. So we already have a 4 here. We carry 2 here. Now the rest of the number here is 44, isn't it? Because we already got 6 4s are 24. Now these two 4s are left, that is 44. Now 6 into a plus 2 must give us 44. Okay, so let's do that. 6 into a plus 2 must give us 44. I hope you understood how we got this. 6 into a plus 2. Now here, let's solve this equation. So here let's take only 6 into a. So 6 into a is equal to 44. Now I'm taking the 2 to the other side, minus 2. So 6 into a is equal to 42. Now we can find the value of a. A is equal to 42 divided by 6, and that is 7. So here, if we put 7 here, then we will get an answer that's 444. That means in the place of b, we should write 4. So we have found the value for b. b is 4, and we just found the value of a, which is 7. So let's write that. So a is equal to 7 and b is equal to 4. These are our answers. So a is 7 and b is 4. Question H, we need to find the values of A, B and C this time. And this is multiplication, and here as you can see, B will be a one-digit number. So B into 3 is going to give us B. So let's write that first. So B into 3 is going to give us B. So again, since it's a one-digit number, it can be any digit from 0 up to 9. So let's take B to be equal to 0. So if B is equal to 0, then B into 3 equal to B will become 0 into 3 is equal to 0. Now, is this multiplication correct? 0 3s are 0? Yes, this multiplication is correct. That means B can be 0. Now, let's try the other numbers also. Let's see which other number gives us the answer also to be the same. So b is equal to 1. Now suppose we take b equal to 1. So here this is b into 3 equals b. So in the place of b we're going to write 1 into 3. In the place of b we're going to write 1. Now 1 3s are 3, not 1, isn't it? So this is not possible. That means b cannot be 1. Now let's see if b can be 2. If b is equal to 2, then b into 3 is equal to 3 is equal to b will be 2 into 3. So in the place of b, we're going to write 2. 2 into 3 is equal to b, which is 2. Now, is this multiplication correct? 2 3s are 6 and not 2, isn't it? So this is also not possible. So b cannot be 2. Now let's try with b equal to 3. If b is equal to 3, then b into 3, that is 3 into 3 should be equal to b, which is 3. Again, look at this multiplication. 3 3s are 9, not 3. That means this is also wrong, so b cannot be 3. Next, let's try with b is equal to 4. So this will be b into 3, that is 4 into 3 is equal to b, which is 4. So 4 3s are 12 and not 4, isn't it? So here this also cannot happen. So this is also wrong. So b cannot be 4. Now you have to remember, when we multiply, the ones digit is what we are looking for. The ones digit should be the same as b and the multiplication should be correct. So this time let's take b is equal to 5. So here b into 3 is equal to 15. That means it's ending in 5. 15. So it is ending in 5, the ones digit 5. So if b is 5, the ones digit also can be 5. That is, if this is 5, this also can be 5. That means it's possible for b to be 5. It's also possible for b to be 0. These are the two numbers that we have got. It's possible for B to be 5 because when you multiply 5 into 3, we get 15, where the ones digit is 5. Same as B. The ones digit and B are the same because here B and the ones digit should be the same. So let's keep B to be 0 and then we'll try with B to be 5 also. So now we have B to be 0 or it can be 5 also. So we're going to begin by writing only 0 first. So now let's rewrite the question by substituting B for 0 first. So here we have AB, that is A0 into 3 will give us CA0. And this first part is true. A into 3 is 0 into 3 is 0. So that part is correct. Now let's go on to the next one, that is A. Now A into 3 should also end in A. A into 3 should end in A. So let's start that. So same way, A into 3 should end in A. That means just like we found out for B, we tried with 0, 1, 2, 3, 4, 5 and we found out that B could be 0 or 5. Similarly, here also A can be 0 or 5. Because just like B, now B into 3 is equal to B, same way A into 3 is equal to A. So A can be 0 or A can be 5. Now if I make A 0, suppose we say A is equal to 0, let's try and work out the sum with 0. So here it is A 0 into 3. So let's write that. So that will become A is 0, B is also 0 into 3. So here we'll have 0. A is also 0 and now we have C. Now C will also become 0, which does not make sense, isn't it? Your product is all 0, it doesn't make sense. That means A cannot be 0. So let's try and see if A can be 5. So if A is equal to 5, so in the place of 0, suppose we say A is equal to 5, then A into 3 should end in A. So that is 5 into 3 is equal to 15 and the one digit here is 5, ending digit is 5. So A can be 5. So let's put 5 in the place of A and see what we get. So here we have A, B into 3 and B we said is 0, we are trying with 0. So A 0 into 3 should give us all this. Now in the place of A we are going to write 5. So 5, 0 into 3, let's see what we get. 3 zeros are 0, 3 fives are 15, carry 1 which we put here. Now this is B and this is B, so both are 0. Now this is A and the second digit is A. So here also we have 5 and 5 is the same. And we've got C. So now we've got our answer. So A is 5. B is 0 because B and B, A and A is the same and C is equal to 1. So let's write that. So A is equal to 5. B is equal to 0 and C is equal to 1. So these are our answers 5, 0 and 1. So here there was no need to substitute with 5 because we got our answer with 0 itself. Question 9, here also we have to find the values of A, B and C. Again, AB into 5 is CAB. That means B into 5 is B. B into 5 should give us back B in the ones place. We did the same thing for the previous one. We did B into 3 and whenever we substituted B with 0, 1, 2, 3, 4, 5 and so on, we found that only when B is 0 or when B is 5 do we get the same thing when we multiply. So here, if B is equal to 0, if B is equal to 0, then 0 into 5 is equal to 0. That means B can be 0 or it can be 5. B is equal to 5. Let's try with B is equal to 5. So here it is B into 5 is B. So let's see, 5 into 5 is ending in 5. It's ending in 5, isn't it? So we've got B to be 5 and here also B is 5. That means B can be 0 or B can be 5. Same thing with A because same thing we write here, we say A into 5 is equal to A. So if A is equal to 0, then 0 into 5 is equal to 0, which is correct. 0 into 5 is equal to 0. 0 5s are 0. That means A can be 0. Now, A can also be 5, isn't it? A can also be 5. So, if A is 5, 5 into 5. 5 into 5 is equal to 25, which is ending in 5. So if this is A, it's ending also in A. Now, in the previous question, we found that if B is 0 and A is also 0, it doesn't make sense, isn't it? So we leave B at 0 and A, we are not going to put 0. Instead, we are going to leave A at 5. So we're going to take B to be 0 and A to be 5. So let's write that. So A is equal to 5. B is equal to 0. Let's see if we can work the sum out. AB into 5. So AB into 5. Let's see what we get. 5 zeros are 0. We got back B. 5 fives are 25. We got back A. We carry 2. So that 2 we write it here. So did you see that? B when it is 0, we got 0. A when it is 5, we got 5. In the place of A and B, we got 5 and 0 because it is 5 and 0. And C is equal to 2. So let's write our answer now. A is equal to 5, B is equal to 0 and C is equal to 2. So these are our answers. Question J, we have to find the value of A. Now let's take the ones column. 5 plus A is equal to 3. That means the ones column should be a number that's ending in 3. So 5 plus A is equal to 3. 5 plus A is equal to 3. So now let's find the value of A. A is equal to 3 minus 5, which is equal to minus 2. That means A is equal to minus 2. It's not possible to put a negative number there. So here we said 5 plus A is equal to 3. Now let's say 5 plus A is equal to 13. So let's try that. 5 plus A is equal to 13. Now from this, let's find the value of A. A is equal to 13 minus 5, which is 8. Now let's substitute. Now according to this, we found A is equal to 8. So let's substitute for A everywhere and let's see whether we get a correct answer. So here 8. Now here it says A and then 5. So in the place of A, I'm going to write 8. We just found out 8, 5. In the second row, we have 9, 4 and A again, which is 8. Now let's add this up and see what we get. 5 plus 8 is 13. So we write 3, carry 1. 8 plus 1 is 9. 9 plus 4 is 13. Write 3, carry 1. Then here we have 9 plus 1 is 10. 10 plus 8 is 18. Okay, now let's see our answer here. 1, we have it here. A is 8. And did we get A is equal to 8? Yes, we got A is equal to 8. And then we have 3 and 3. So we have checked and we have found that our answer is correct. That means the value of A is 8. A is equal to 8. Question K, here we need to find the values of A, B, C and D. So let's begin with this here first. So here what do we have? 5 plus C. 5 plus C is equal to 1. That means it's ending in a number where the units digit is 1. So now let's find the value of C. So C is equal to 1 minus 5, which is equal to minus 4. So C cannot be negative 4. It cannot be negative 4, isn't it? So now let's take 5 plus C equals 11. So C is equal to 11 minus 5, where C is equal to 6. So we have found the value of C. C is equal to 6. So let's substitute here. So here we have 6, A, B, 5 plus D, 5, 8, C. In the place of C, we're going to write 6. And here the answer is 9, 3, 5, 1. Okay, let's take the ones column. 5 plus 6 is 11. We carry 1. So when we carry 1 here, b plus 1 plus 8 should be equal to 5. So let's do that. B plus 1 plus 8 should be equal to 5. That means b plus 1 plus 8 is 9 is equal to 5. So b is equal to 5 minus 9, which is equal to minus 4. So again, we cannot make b minus 4, isn't it here? So it's a negative number. So here we said b plus 1 plus 8 is 5. Let's make it as b plus 1 plus 8 is equal to 15 and see what we get. Why did we make it 15? Because the digit here is only one digit number. That should be 5. That should be 5. So this can be 1 or 2 or 3 or 4. We are trying with each number. So first we try with 15, then we can try with 25, then we can try with 35 and so on. So first let's try with 15. So b plus 1 plus 8 is 9 is equal to 15. B plus 9 is 15. So B is equal to 15 minus 9. So B is equal to 15 minus 9 is 6. And we can take B as 6. So let's substitute here wherever we have B. Let's put 6 in that place. So let's write that 6. A we don't know. B is 6. Then we have 5. Then D 5. 8, 6, 9, 3, 5, 1. So what did we do? In the place of B, we wrote 6. Now let's check the addition. 5 plus 6 is 11, carry 1. 6 plus 1 is 7. So we have carried 1 here. 6 plus 1 is 7. 7 plus 8 is 15. That means we carry 1 here. So we carry 1 here. Now let's look at the third column here. A plus 1 plus 5 is equal to 3. So let's write that. A plus 1 plus 5 is equal to 3. That means A plus 6 is equal to 3. Now if we have to find the value of A, we say A is equal to 3 minus 6. That is A is equal to minus 3. That's not possible. It's a negative number. So this time let's say a plus 1 plus 5 is equal to 13. Instead of 3, let's say 13. Always take the smallest number. So here I can say a plus 6 is equal to 13. Or I can find the value of a by saying a is equal to 13 minus 6. That is a is equal to 7. So we have found the value of a also. So in the place of a, let's put 7 and see whether it works out. So here we have 6a, b, 5, we have found b and c. Let's put a 7 in the place of a. So let's write that 6a. So in the place of a, we are writing 7. B is 6 and then 5. D 5, 8, 6. All this on adding up should give us 9, 3, 5, 1. So let's do that. 5 plus 6 is 11. We carry 1. Then here we have 6 plus 1 is 7. 7 plus 8 is 15. Correct. Carry 1. Now here we have 7 plus 1 is 8. 8 plus 5 is 13. Carry 1. So it's correct so far. So this is 1. Now 6 plus 1 is 7. 7 plus D is equal to 9. So let's write that. 7 plus D is equal to 9. That means D is equal to 9 minus 7 or D is equal to 2. So we have found the value of D also. D is equal to 2. So let's substitute it here and see whether we get this answer. So D is equal to 2. Let's substitute. So in the place of D, we're going to put 2 and see what we get. So we have 6, 7, 6, 5 plus D, we are writing 2, 5, 8, 6. Now let's add this up and see what we get. 5 plus 6 is 11, carry 1. 6 plus 1 is 7 plus 8 is 15, carry 1. 7 plus 1 is 8, 8 plus 5 is 13, carry 1. 6 plus 1 is 7, plus 2 is 9, 9,351, which is the same as what is given to us in the question. That means we found the values of all the numbers. Let's look at the last part. From this we can find the value of all the numbers. Now 6a. Now 6a, that means a is 7. So let's write that. A is 7. Now we need to find b. Let's go back to the question. B is next to a. So next to a is b and b is 6. Now let's find the value of c. And c is in the ones place here. So in the ones place here, ones column, here we have c is equal to 6. Then the last one is d, which we just found out. D is here and 6 plus d is it. So this part d is here at this end and that is 2. D is equal to 2. So we have found our answer. A is 7, B is 6, C is 6 and D is 2. Question 9. For a 3-digit number ABC, what will be the quotient if ABC minus CBA is divided by 11? So the first thing that we can do is we can try and expand this. That is, if I take A, B, C, it's a product, isn't it? A into B into C. C is in the ones place, B is in the tens place and A is in the hundreds place. So if I have to expand this, this becomes 100 into A plus 10 into B plus C. Similarly, if I take C, B, A, now this is also going to be 100 into C plus 10 into B plus A. So now what does the question say? If ABC minus CBA is divided by 11, what do we get? So let's put out this form. That is ABC minus CBA is equal to, now this part, that is the expanded form of ABC minus the expanded form of CBA. So I'm writing only that subtraction first. So ABC is 100 into A plus 10 into B plus C. So this one minus 100 into C plus 10 into B plus A. So this is what we have done. This part we have written the expanded form. Now divided by 11. So here we are dividing this by 11. That means this whole thing is also divided by 11. So now we are going to simplify this. We're going to remove the brackets. So that will be equal to 100 into A makes it 100A plus 10 into B will make it 10B plus C minus, now here 100 into C is 100C plus 10B plus A divided by 11. This time we're going to remove the brackets. So this is going to be 100A plus 10B plus C minus 100C minus 10B minus A. So now this is divided by 11. Now let's take the like terms together. So here we have 100A and here we have 1A. So 100A minus 1A is 99A. Then here I have plus 10B and minus 10B which get cancelled because one is negative, one is positive. Then here I have plus C minus 100C. That means 1 minus 100 which is minus 99. Minus 99C by 11. We have simplified this. Now 99A minus 99C. 99 is common, so we're going to take it out of the bracket. So this is 99 and put the rest inside the bracket. A minus C by 11. Now here this is multiplication, so we can cancel. We can cancel 11 and 99. 11 ones are 11, 11 nines are 99. So what is left is 9 by 1 into A minus C, or the final answer is simply 9 into A minus C. So this is a final answer. With this we come to the end of our exercise. Thank you, children.